If you fell feet first toward a black hole, would it crush you? Not exactly. Your feet would be pulled so much harder than your head that gravity would draw you out, unzipping you into a thread of atoms. The process even has a nickname. Scientists call it spaghettification. It sounds playful. It is one of the most violent ends the universe has to offer. Picture yourself hanging over that dark circle in space. No glow, no surface, just a patch that eats starlight, a perfect hole in the fabric of the universe. You dangle with your boots pointing down. You feel a pull that grows every second, a silent, patient summoning from the void. Your body begins to feel longer than it should. Most of us imagine a giant press, a cosmic trash compactor, but that is not what a small black hole does to you. It pulls on your feet more than it pulls on your head. The danger is not the strength of gravity itself, but the difference in its strength across your body. The near side falls harder than the far side. That is what tears you apart. You know this force. We call it a tide. The moon pulls on the Earth's near ocean a little more than the far ocean. Water bulges. Beaches breathe in and out by about a meter. That tiny difference in pull across 12,000 kilometers of planet is enough to move whole seas. But on our scale, it is gentle. Now, imagine shrinking that source of gravity into a tiny space. Take the mass of 10 suns, cram it all into a sphere the size of a city, then hold your 2-meter-tall body near that concentration of space-time curvature. The same kind of tidal difference turns violent. What once nudged oceans now fights your very bones. Let's meet our object, a simple, non-spinning black hole, 10 times the mass of the sun. Its edge, the point of no return called the event horizon, is about 30 kilometers across. That is a morning drive around a small city. Anything that crosses that line, even light, cannot escape. It is the last exit on a one-way road. Just outside that edge, at about 45 kilometers, light could loop once and leave, a tight racetrack for photons. A little farther out, at about 90 kilometers, is the last place anything can maintain a stable orbit. Inside that line, you can circle for a time, but you will always spiral in. Here, in the deep end of the gravity well, small distances matter a great deal. From far away, you feel normal. Space is quiet, and the pull changes so slowly it feels like any other distant star. But as you fall closer, gravity stops being a simple backdrop. It starts to have a steep slope across your body, and the view begins to warp. The stars behind the hole are bent into strange arcs of light, a cosmic funhouse mirror. At around 10,000 kilometers out, your feet begin to feel a shade heavier than your head. It is like standing on a very steep hillside that runs through the length of your body. You would not panic yet, but your balance would feel off. Your inner ear would argue with your eyes about which way is down. Near 8,100 kilometers, the difference from head to feet reaches about 1 G. That is the same pull you feel on Earth, but stretched across just 2 meters. You would feel yourself lengthen a touch. Your core muscles would tense without you telling them to. Blood would try to slide toward your feet no matter how you twisted. By a few thousand kilometers out, the gradient turns personal. Your tissues are not one solid block. They are a community of connected parts. And that community is being pulled into a civil war. Tendons, muscles, vessels, nerves, each part tries to fall at its own speed. The connections strain. Your own body begins to fight itself, every cell pulled in a slightly different direction from its neighbor. At about 3,000 kilometers, you would feel that strain as a deep, relentless pull. Your gait would fail. Your breath would hitch. You would not feel pressed. You would feel pulled apart. Long ways. The way taffy thins when you stretch it between your hands. Around 1,000 kilometers from the center, things snap. Your feet are now being yanked with a pull 500 times stronger than Earth's gravity compared to your head. No living tissue can smooth out that difference. Bones and tendons cannot share that load. Seams open, starting from your boots and moving upward. This is the end of a person as a person, long before the event horizon. Clothing tears, skin parts. But the unraveling goes deeper. At a few hundred kilometers out, the tidal forces overwhelm the chemical bonds that hold you together. Molecules unzip. Water and soft tissues separate first, creating a stream of organic material that keeps its shape only because the lower end is dragged so much harder. Then, atoms themselves lose their grip on their electrons. You become a glowing filament of plasma, a thread of charged particles shining from the sheer violence of the stretching, feeding the dark. By the time you are 100 kilometers out, the gradient across what was once your body is hundreds of thousands of G. Only bare atomic nuclei and electrons line up in that stream. The thread of what you were shines and thins as it accelerates, a river of ions flowing into the night. And here is the strange truth. The event horizon is not the kill zone for small black holes. At that 30-kilometer edge, the tidal difference would be around 2 million G, but there is no person left to feel it. You were undone far outside, a casualty of the steepening slope of space-time. And what would you see in those final moments before you were undone? The view would be unlike anything else. The black hole in front of you would block out the stars, but the sky around it would be warped. All the light from the universe behind you would be bent and focused into a bright ring, a single distorted window onto everything you left behind. The entire cosmos squeezed into a halo of light around the abyss. Time plays its own tricks here. From the perspective of your own wristwatch, if you could have one, the moment you cross the horizon of this 10-sun hole, the end is almost instantaneous. The fall to the center is over in about 150 microseconds. That is just over a 10,000th of a second. Your entire remaining existence is shorter than the time it takes for a camera flash to fire. But to faraway eyes, you do not drop in. You slow down. Your light reddens and fades as it fights its way out of the gravity well. Your last image seems to hang near the rim, frozen and dimming for eternity. Two stories told at once, your near-instant end and their endless, fading memory of you. Now change the scale. Our galaxy's center holds a supermassive black hole named Sagittarius A*. It weighs 4 million suns. Its event horizon is enormous, about 12 million kilometers wide. That is a vast cosmic sea compared to the city-sized pond of a stellar black hole. Here the tides at the horizon are gentle. That 1G difference that started your trouble before, it does not show up until you are 600,000 kilometers out. The horizon is still millions of kilometers farther in. You could drift across that vast edge and feel nothing. No rip, no crush, just a quiet, irreversible transition. The only clue would be the sky. Looking back, the entire universe of stars would now be compressed into a shrinking circle of light behind you, your only window to a world you can never return to. The same physics still waits for you inside. Fall far enough in, and the tidal stretch will grow deadly. But the place where you cross the point of no return is calm. For black holes, big can mean gentle at the boundary, and small can mean violent long before you ever get there. We have made some clean, simple choices in our thought experiment. A fall straight down, no spin, no other matter. Real black holes often wear bright, hot disks of gas and dust. The radiation from one of those could cook you long before the tides ever had a chance. Those details shift the numbers, but not the story of the tides. But the quiet truth remains. You are stretched, not crushed. The fatal force is not the overall pull of gravity. It is the difference in that pull across your body. Your 2 meters of height is enough for the cosmos to notice, enough for it to grab your shape and pluck it like a string. And that is the part that lingers. We are small, but we are also precise. We walk around built to a scale that the universe can feel in ways we might not expect. A black hole does not hate you. It simply has no reason to treat your head and your feet as if they were in the same place.